Hello guys, in today's video we will be discussing on the question the number of distinct islands. This is one of my favorite questions in the topic of graph because this will require you to put a bit of your effort, and it is not that simple. You'll have to go through multiple cases, and how do you okay, let us first read the question and understand what they want us to do. Given a Boolean 2D matrix grid of size n into m, you have to find the number of distinct islands where a group of connected ones horizontally or vertically forms an island. Two islands are considered to be distinct if and only if one island is not equal to another, not rotated or reflected. What does this mean? We are given with this 2D matrix. 2D matrix has n rows and m columns, and it is given as n into m, so n rows and m columns. And all we have to do is to not find the number of islands, but to find the number of unique islands. How do we do that? We have already done a question in which we have to find the number of islands, which in this case will be 2, of course, because these 4 will form a connected component and these 4 will form another. And in this case, we'll get how many? 1, 2, 3, and 4. But if we take only the unique cases, how many will be the number of unique islands? This is equal to this, because if we superimpose this on this, it will be same. And it is said that it should not be equal in terms of rotating, even after rotating it or reflecting it. So if we reflect it, it will be same, right? So this will be counted as one single entity and not 2, because these are same. And similarly in this case, we have these 3 combining to form one island. We have these 2, this 2, and this 3. But you see, this is a reflection of this, is it? No, this is not. This is not, because since if you put this on this, will they match? No, they won't. So these are not identical. And if you put this on this, they'll be identical. So the number of identical islands will be these 2, right? So number of unique islands count to how many? Will include these 2 to be one island, and this to be another, the second one, and this to be the another third one. So we'll have 3 different islands in this case, which is marked here. The green color we have one island, the red the other, and the blue the third one. So that is how we have to at least see to how to approach this question. So having understood what exactly we have to do, the time and the space complexity is n into m. So the approach that comes to my mind is to only find the number of unique islands. Find the number of all the islands and then put that into a set, and set will take care of the uniqueness, right? Set has a feature that it only keeps in it the unique values. So is it feasible that we give these 2 islands in the set and make them a single island? Set will take care of it. No, set won't take care of it, because if we give these 2 as an island, the indexes of these 2 are different, right? So set won't recognize this island to be same as this island. So what we have to do is to generalize all the islands in terms of one index, right? Generalize all the given islands in terms of one index, and then put that into the set. And since the indexes are same that are getting used, set will take care of itself, like to find to keep in it the unique elements. So how do we do that? Let's say, what is the index of this? The index of this is 0, 0. Fine, let me just copy this down. Hopefully I can. I don't know. Yep, I can. So having taken this into, so this one is 1, 0, 0. So the first set of island will have 0, 0 in it. The second index, that is of this, will be what? We can either take this or this. I'm going with this. We'll have 0th row and first column, so we'll have 0, 1. Third element of this island will be 1, 0, and the fourth will be 1, 1, first row and first column. Having done that, let us now write the indexes of this island, the second one. How will we do that? We'll simply find the index of the first one, that is this, which is in the third row and in the fourth column. That is, taking 0 based indexing into consideration, we'll write third row means 2 and fourth row means 3. Now this will be in the second row, like 0, 1, 2, like third row and fifth column. So third row and fifth column. Third row and fifth column. This index will be what? This index will be, wait, 0, 0 is fine, 0, 1 is fine. So we go from here to here, but then we cannot go here. If we have taken this as the path, if we have taken this as the path, we'll have to touch this after this. So, and then only we can go to this. So I will have to change ordering a bit. Like it is 0, 0. Then we go to 0th row first column. Then we'll have to write first row first column, and then is when we can go to the first row and first column. Similarly here we have first went to this second row third column, second row fourth fifth column, second row fourth third row fourth column, third row fifth column. Then we'll go to what? Fourth row fifth column, and then we'll go to fourth row third column, right? Now fourth row fourth column, that is 4, 3. Fine. Yep, that is what we had to do. And now all we have to do is to relate this in such a way that set identifies this as equal. If the set if you put this directly into set will consider this to be 2 different islands. Why so? Because these are of course like 2 different indexes, right? So how do we convert this in such a way that it goes to this? We do that by simply subtracting all the indexes with its parent index. The parent index here being the first index, that is 2 and 3. And what is the parent index for this? The parent index of this is 0, 0. Now subtract. We'll find, I will write the converted form. We'll do this for all the islands, mind you. So if we do that, 0 comma 0, 0 comma 0 minus 0 comma 0 is same 0 comma 0, so we'll put it as it is. We'll put this as it is. Since we're subtracting this with 0, it is effectively the same, right? So we can just copy this and paste it here as it is, because you're subtracting it with 0, right? It won't have any sort of difference. Now we'll convert the second island, converted form. Here is when you see the difference, and here is, wait, here is how you see the difference. 2 comma 3 minus 2 comma 3 is what? 0 comma 0. 2 comma 3 minus 2 comma 3 is 0 comma 0. What is 2 comma 4 minus 2 comma 3? 2 comma 2 is 0. You just subtract the consecutive x and y terms. 2 comma 2 is what? 0. And 3 comma 4 is what? 1. I mean, you take the absolute value. No, you should not be taking the absolute value. Once again, 2 comma 3, okay. 2 comma 4, okay. 0 comma 0th row, first column. Yes, same row, other column, right? Then 1, 2, 3, third row, fourth column, fine. Yep. So if you subtract 0, yep, yeah. You're subtracting 0 comma 1, you'll get what? You'll get minus 1, right? I mean, 1 comma 0, no, you'll get 1 only, yeah. Yep, 0 minus 0, yeah, you'll get same here, yeah. 4 minus 3 is minus 1, yep. And if you go to this, if you subtract this with 2 comma 3, 3 minus 2 is what? 3 minus 2 is 1, and 4 minus 3 is 1, right? And the fourth one, you'll see 4 minus 2 is 2, yep, 4 minus 2 is 2, and 3 minus 3 is 0. I guess we are missing out on something. Let me recheck it once. 0, 0, 0, 1, 0th row, 0th column, 0th row, first column, first row, first column, okay, first row, 0th column, and first row, first column. Yeah, that was something we were missing. Okay, right, first row, first column, 0th row, first column. Yep. Yeah, and here 0, 1, 2, second row, 0, 1, 2, 3, 4. So 0, 1, 2, 3, 2 comma 3 correct, 2 comma 4 correct, and then we go where this, right? So 1, 2, 3 comma 4 correct, and then 0, 1, 2, 3, 3 comma 0, 1, 2, 3, right? 3 comma 3, right? Yep. So 3 comma 3 minus 2 is 1, and 3, yeah, 0. So this is 0, 0, 0 minus 1, 1, 1, and 1, 0. Yep. Oh. Now I guess we are ready with the, I was just missing out on some index, and I was just confused because it is already 2:15 a.m. at night. And yep, so yeah, so if you see, we have this first island, which is from the 0, 0, 0, 1, 0, 1, 0, 1, 1. You subtract all the values with the what? With the base value, I mean the parent value that starts the island with. And you do that for this, since it is 0 comma 0, you get the same value back. And for this, you get, if you subtract all the indexes with 2 comma 3, you'll get what? The same index. So set will identify this as what? Unique element, right? Set will identify both of these as unique element, because set would not store duplicates. In that case, on returning the value of the set size, we'll get the number of unique items. That is the approach. Let me code this down. I hope it took a bit of time, because said, right, this is 2:16 a.m. in the morning, and it is, I mean, sort of, my mind is boggling around. Let me store the value of n in the greet dot size. We'll store the value of number of columns in 0 comma size. I hope you would have known this by now. It is this. This is number of rows, and this is number of columns. Now what? Now you'll have to initialize the set, which will have the number of islands, right? Islands is in the form of vector of int. This is what set you can call st, and you'll have to return set cost size. You'll have to put all the islands into the set, and you just have to return the value of its, value of the size of the set. So that is what you have to. Now, how do we find the unique elements is what we'll do now. What? We'll traverse all the elements, right? I is less than n, I plus plus. We go to is equal to 0, j is less than m, yep, j plus plus. When do we check for an island? We only check for an island. Well, basically, I hope you would have understood by now that we'll be using the DFS approach. Why so? Because we have done that in the number of islands question also. Only when when we'll call DFS, right? We'll call DFS only when we encounter 1. So if grid of I comma j is equal to 1 is only when we call the DFS. DFS will pass what? Will pass I comma j, and we'll have to see this DFS will start from here, and it will go to here, then it will come to this one, and then it will go this side. So we'll have to store the value of this index, right? We'll pass this again in order to store that ij. We'll have to pass this twice. One to traverse, and 1 to store the value of the index. Like, we'll have to subtract this at the end, right? So 1 to traverse from here to here to here to here, and 1 to store the value of the base index. So we'll put this ij, and then we'll pass what? We do not want to pass set, or do we? No, we do not. But we'll have to make a temporary island that will store the value of the islands that will have, right? See, these two will be counted, right? Only after counting is when we find if it is unique or not, right? We'll have to traverse this, we'll have to traverse this also, and then we'll have to subtract this and then push that into the set. We'll push this also into the set, and we'll push this also into the set, and set will take care of the uniqueness. But we'll have to find this at least, right? Both of them. So we'll do islands. This is a temporary vector. which will, of course, every time we call the function, it will be re-declared, and hence we do not want to clear it back again every time. So we'll pass what islands, and we'll pass grid. Having done that, I will have to push island into the set islands, because only after finding the islands we'll push that into the set will take care of the uniqueness, and we return the size. That is all we have to do in this question. Now what? Now simply we have to call the DFS function. Void DFS. We'll have to take I, j, and this is the variable ij that will play with, that will play around to the DFS traversal in itself. Now we'll have to store that initial index in a variable, right? We'll use x and y for that. Now vector int islands, and what, which is the fourth one? Yep, grid. Vector int percent grid. Fine. Having done that, we'll store the value of grid dot size time is equal to grid 0 dot size. Having stored these values, we'll check if the DFS traversal is possible or not. Let's say the only case when the DFS traversal won't be possible is when it goes out of range, or is it not one. First of all, we'll check I is less than 0, or j is less than 0, or I is greater than or equal to n, or j is greater than or equal to m, or grid of I comma j is not equal to 1. Why do we use this? You would be thinking, why did I use this case if we have already mentioned to call DFS only when it is 1? No, that is not the case here. This is a recursive function. It will go from this one to this one, this one, this one. But let's say it can also encounter this 0, right? It can also encounter this 0, right? Because we'll plus it, of course. And these are the cases when we return back. These are the cases when we come back to this and tell that no, you cannot go further. It is the end of the DFS traversal. When do we end? It is when the I approaches, negative side, or I increases, more than the number of columns, or number of I increases number of rows, it increases this side, or j increases number of columns this side, or we encounter these set of zeros. So it is then we return back. And if it is a valid case, what we'll do? We'll mark grid ij as 0, because we do not want to come back again, right? So we'll mark this as 0. Okay, your DFS traversal, for this one, your DFS traversal is done. Now you can be 0 now, and for this also it is 0, and it will go on, right? So it will convert all these as zeros, so that if, let's say, while counting for these ones, we do not encounter these again. So that is what. Having done that, we'll have to push into the islands. What do we have to push? We'll push into the islands the values I minus x, not I and x. It is I minus x and j minus y. Why? X and y are these initial indexes I have showed you, right? This 2, 3 is the initial index, and these are ij values that will keep on changing, right? But I'll show you it. After doing that, we'll call DFS for I plus 1 comma j comma islands comma grid. Fine. I plus 1 j, I j plus 1, I minus 1 j, I j minus 1. We have called this. Now what? See, these are the indexes that we are playing with. 2, 3 gets converted to 2, 4, 2, 4 gets converted to 3, 4, and these are the indexes that are variable. But we need this one index to be constant. What is that? That is nothing but x and y. That is nothing but x and y. So x and y is 2 by 3, 2 and 3 in this case. And these are the variable. I, j are all these. Initially it is 2, 3, then it is 2, 4, and then what are we inserting in the island ka vector is this, not this. We are subtracting 2, 3 with x and y is 2, 3 itself. So we're subtracting that and putting this, and we're subtracting 2, 3 from this and putting this. So this way we'll store the uniqueness, because after getting, what do you say, island values, they're putting that in the set, right? And set will take care of the uniqueness. So I guess that was all about this question. Let me I plus 1 j. Okay, wait, yeah, I and j is what you have to pass as well, right? I and j. Let's see. Yes, let me submit this and see. Did we miss on something? Plus 1 j, ij plus 1, I minus 1 j, ij minus. Called for everything. Taken this. So times ij. Everything seems correct to me. I minus x, j minus y. But ij is 0. This. Do have to pass this, of course. What are we missing on? Vector and ij, x, y. minus 1G. Hmm. Price. Let me once check the mistake was very vague. We did not have to pass I and J, we had to pass X and Y. And these small errors takes a lot of your time at times. Luckily, I was able to find this quickly. Yep, this should be fine, I guess. Yes, it is. So that was all for this question, guys. I hope you would have understood the approach. The approach was, I mean, it was simple once you understand, but then how did we make these a unique islands is all we had to take care about in these questions. We just had to subtract this with the parent value, like the node that was starting this island. So that was all about this question, guys. Until next time, goodbye.